Today we're going to begin discussing sampling distributions. By the end of today's lesson, you should be able to distinguish between a parameter and a statistic, and you should be able to use a sampling distribution of a statistic to evaluate a claim about a parameter. So let's distinguish between some important vocabulary. The difference between a statistic and a parameter. So a statistic is a number that describes a sample. So I often say, remember S and S here. Whereas parameters are numbers that describe population. So our P's go together. We have a different notation that we use for statistics and parameter to help us differentiate between the two. So first of all, when we're talking about a mean, we use X bar, and X bar is estimating our population mean. So I'll put this over here. So this one is our statistic, X bar, and mu is our parameter. So when we talk about proportions, so this is an abbreviation, this prop is for proportions. That's where I'm talking like percents, a part of a group. We use a P for a proportion, and we use P hat for the sample proportion. So again, our statistic, P hat, is estimating our proportion. When it comes to standard deviation, we use S, sometimes S sub X, for our standard deviation of our sample. And then we use sigma, Greek letter again, for our population parameter here. So S estimates sigma. Sampling distributions show the value of a statistic, so it could be the mean, it could be the proportion, or it could be something else, found in all possible samples of size n, and I'll show you this with a graphic shortly. And this is different than a population distribution because that's just showing all the individuals in one population. Let's go through this first scenario. To determine how much homework time students will get in class, Mrs. Lynn has a student select a simple random sample of 20 chips from a large bag. The number of red chips in the SRS determines the number of minutes in class students get to work on homework. So Mrs. Lynn claims that there are 200 chips in the bag and that 100 of them are red, so half the bag. When Jenna selected a random sample of 20 chips from the bag without looking, she got 7 red chips. Does this provide convincing evidence that less than half of the chips in the bag are red? Okay, so let's begin first of all by recognizing our vocabulary. We're going to identify our population, the parameter, sample, and our statistic. So the population is our entire group of 200 chips. And then Jenna draws an SRS of 20 chips. The parameter would be a proportion. So we're talking about what part are red here. So in this, the parameter would be 100 out of 200 is the claim that Miss Lynn makes, or 0.5. Now, the statistic is P hat, again, is how that is read. The statistic would be how many Jenna drew in her sample. So 7 out of 20 is 0.35. So next we're asked, what's the evidence that less than half of the chips in the bag are red? Or what's giving us this suspicion, in other words? Well, the sample had 7 out of 20 chips that were red. This is less than 50%. So now we're supposed to provide 2 explanations for this evidence. So in other words, what could really be happening here? Well, one thing is this is a chance process. You reach in and you draw 7 chips. Perhaps it happened purely by chance. So I've stated we drew 7 out of 20, 0.35 red chips purely by chance. But you know what? Maybe there's something else going on here. Maybe, if the teacher's like me, perhaps they're being less than honest here. Maybe there's not really 100 red chips in the bag. Maybe she put a lot less in there because she doesn't really want to give that much time for homework and just told the kids that half the bag. So maybe there are less than 50% red chips in the bag. In other words, the teacher is lying. What teacher would ever do that? Well, to get a sense of this, let's look at what a sampling distribution is by looking at some of these graphics here. Okay, so here's the claim, right? Teacher says we've got 100 blue and 100 red in the bag, so the population parameter is 0.5. Okay, so we are going to, you could draw some samples, okay? So an SRS of size 20, drawing 20 chips. This is showing 12 blue, 8 red. So the p hat, the proportion that are red in the sample, this is a statistic, is 0.4. Here's a different SRS of 20 and how it could play out. So it looks like 9 blue and 11 red. So my p hat, 11 out of 20 is 0.55, okay? So how many times do we do this? How many different samples do we draw? Well, the total of them, every possible single one, and if you graph the p hats here, this is known as a sampling distribution. It is all the different statistics found in all the possible samples we could possibly pull out of that bag of size 20, okay? Look what happens here. This is our sampling distribution, and this is saying this is actually 500 different SRSs of size 20 right here. And we've created this dot plot, so the dots have like mushed together here because there's so many. Let's see if we understand what the sampling distribution is showing us. It says there is one dot plot on the graph at 0.8. So here it is, right here. Explain what this value represents. This means that there was just one sample of size 20. Okay, make sure you always state the size because this is every one of here was a sample of size 20. There was one sample of size 20 chips where 80% of the chips, which would be 16, were red because 80% of 20 is 16. So each dot on here is one sample of size 20 and finding the proportion of red of that size 20. So at the beginning, Jenna drew a sample of size 20 and only got 7 red. So would it be surprising to get a sample proportion of p hat equals 7 out of 20 or 0.35 or smaller? Okay, so that or more extreme is what it's saying. So where is that? That would be, let's see, I'll highlight on my dot plot. That would be from here over, okay? Is that unusual? I'm going to say that no, it's not, because a sample proportion p hat of 0.35 or less, okay, because I'm always looking at that, or more extreme, happened, well, I don't know the exact percent of the times. I'm just going to say that happened pretty often. If we look at those frequencies, there's quite a few dots in that area. So, it's not as likely as getting 0.5 or 0.45 as we see there in the distribution, but it's happening pretty often. So it's not like it couldn't happen. So based on these previous answers, is there convincing evidence that less than half of the chips in the large bag are red? Explain your reasoning. So take a second, think about this. And we've kind of stated it already, but I would say no. There's a large enough chance that we get a sample proportion, which we call p hat, of 0.35 or less just by chance. Now, if it were out here, that she had drawn her sample, would that be unusual? That possibly might be unusual, but we would have to really calculate it, which we'll learn to do to see if it's really statistically significant.